Example 2, part A says, how long does it take to reach the maximum height? So if we look at this path of the ball, it starts at time equals 0, it's on the ground, it goes up for a while, and then it comes back down. I know that that is the path of the ball, or the, how it's moving over time, because I look at the position equation and it has a t-squared term. A t-squared term means it's a parabola, and negative means it's upside down. So if you were to graph the position equation on a graphic calculator on Desmos, you can see this would be the shape. So this is what I'll be referring to. It's asking me in part A, how long does it take to reach the maximum height? Well, what I want to do is try to ask myself that question in terms of calculus. So how long does it take to reach the maximum height? If I look at the ball here starting at the bottom, and then it climbs up, 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 up. I want to know how long did it take to get to that spot right there in the middle at the vertex. I want to know, how long, or what is the t value for that spot. Now, I would like to reword this or think about it differently in terms of calculus so that I can answer the question using this equation. And if you look at that dot that I have there, that point's at the very top of the parabola, it's at the vertex. And if I did a tangent line, the slope the slope of the tangent line at that spot would be 0 because it's a horizontal tangent line. So if I'm asked how long does it take to reach the maximum height, I look at the picture, the maximum height will always be at the vertex, and the vertex point would have a tangent with a slope of 0. So if I already know what the slope of my tangent line is at that point, my plan's going to be do the derivative. The derivative in this case is the velocity. We talked about that up here. If you have a position equation and you do the derivative of it, it's the velocity. So when I do the derivative of my position equation, I'm going to be looking at my position equation here. If I do the derivative of that, I'll get a velocity equation. It'd be negative 32t plus 160. That's just using the power rule. If I have a velocity equation and I already know what I want my slope to be, I'll set it equal to what I want my slope to be, which is 0. So I will get solving. I'm going to add 32t to both sides. Divide by 32, and it is 5 seconds. That means the time it takes to get from the starting point on the ground all the way up to the top of the path is 5 seconds.